Now we are going to discuss three problems on motion problems, good for grade 9 students. The first one states that Olga rides her powerboat up and down the Agno River. The water in the river flows at 5 miles, or rather 6 miles per hour. Olga takes 5 hours longer to travel 360 miles against the current than she has to travel 360 miles along with the current. What is the speed of Olga in still water? No? So, as you know, we're going to make use of the distance formula, which is rate is equal to rate times time is equal to distance. No? So, if we represent x to be the speed of Olga in still water, and this is our unknown, no? Since the problem states that the time is equal to the difference between the upstream time is equal to 5, no? So time is equal to distance over rate, no? So for our t sub 2, that is equal to 360 over x minus 6, and minus 360, that is t sub 1, over x plus 1, x plus 6 is equal to 5. Now we make a table here for upstream. If x is the speed of Olga in still water, x minus 6, which is 6 is the speed of the river, or the river at 6 miles per hour, no? So t sub 1 is equal to t sub 2, and the distance is equal to 360. For our downstream, x plus 6 will be our rate, no? That is along with the current, and that is t is equal to t sub 1, and the distance is also 360. No? If we are going to solve this equation here, we're going to multiply the whole equation by the LCD, which is x minus 6 times x plus 6. Doing that, we have this equation here, 360 times the quantity x plus 6 minus 360 times the quantity x minus 6, that is equal to 5 times the LCD, which is x plus 6, and times the quantity x minus 6. So we're going to we're going to combine our constants, which is equal to 4,320, and that is equal to 5 times the quantity x squared minus 36. And then we distribute 5, that is making use of the distributive property of algebra, or equation, that is 5 times the quantity x squared minus 36. So this is equal to x squared minus 36, which is equal to 864. Solving for x, no? X squared is equal to 864 plus 36, which is equal to 900. Getting the square root of 900, we are going to get x is equal to 30. That is the speed of Olga in still water. For our problem number 2, we have here, a certain boat traveled 32 kilometers along with the current and 60 kilometers against the current. In the same amount of time, find the rate of boat if the rate of the current is 2 kilometers per hour. Similarly, we represent x to be the rate of the boat in still water. And in this case, our time is constant, no? The problem says that at the same time, find the rate of the boat if the rate of the current is 2 kilometers. So our time is constant, no? As we know, making use of the distance formula, time is equal to distance over rate. So upstream time is equal to 16 times over x minus 2 is equal to 32, which is our downstream time, 32 over x plus 2. Again, we solve for the value of x and get the LCD of this equation here. So LCD is x minus 2 and x plus 2. So we are going to have this equation here, 16 times quantity x plus 2 is equal to 32 times quantity x minus 2. That is cross multiplication. So solving for x, we have here, we distribute 16 here. 16 times x plus 2 is equal to 16x plus 32. And this one is 32 times quantity x minus 2 is equal to 32x minus 64. We combine like terms, no? So this one is 32. X minus 16x is equal to 16x, and we combine 32 and 64, we have here 96, and solving for x, we get x is equal to 6. So this is the value of the rate of the boat in still water. For problem number 3, the problem states that a boat travels for 3 hours with a current at a speed of 10 kilometers per hour and returns the same distance against the current an hour more. We are asked to determine the boat speed in still water. In this case, the distance is constant, no? It does not change, no? And as you know, distance is equal to rate times time, no? Distance is equal to rate times time. So we know that the boat travels 3 hours with a current at speed of 10 kilometers per hour. No? Since the distance does not change, the distance is equal to 30 kilometers. Again, we're going to solve for the value of x here. We let x to be the speed of the boat in still water. For upstream, we have here, upstream, the distance is equal to x minus y, the quantity x minus y times 4, that is equal to 30, no? We equate, no? The distance to this upstream distance, no? So we distribute 4, we get 4x minus 4y is equal to 30, and then, you know, we know that the speed is 10 kilometers per hour. The total speed of the current in the boat, if the total speed is 10 and the current is x, no? The speed of the boat is x. The speed of the current will be 4 times the quantity 10 minus x, no? So we're going to solve for x here. 4x minus 4 times 10 is negative 40. Negative 4 times negative x is equal to 4x. That is equal to 30. Combining like terms, 4x plus 4x is equal to 8x. Negative 40, and then we add 40 to both sides of the equation, we're going to get 8x is equal to 70. We divide both sides of the equation by x, by 8. We get x is equal to 70 over 8, and we reduce this to lowest term, we get 8 times 8 and 3/4 kilometers per hour. So this is the speed of the boat in still water. So that's how we're going to solve this kind of problems, motion problems. So for if you have any needs for bunch tutorial lessons, please contact Mr. Willie Tan at 0956-207-4626 or 0915-202-6933. Again, thank you for watching our videos for today, and please don't forget to subscribe. And if you have any suggestions and comments, please send it to us so that we can respond accordingly, so that we can improve our way of presentation. Thank you again, and see you later.